Okay, so another similar rule in differentiation we're going to learn is something called the product rule. So when the power rule was concerned of how we take the derivative of something raised to a power, the product rule is concerned with how we take the derivative of one function multiplied by another function. Okay, in this case we'll call f of x our first function and g of x our second. So if we take that derivative, that will just be the derivative of our first function multiplied by our second function plus our first function multiplied by the derivative of our second. So given this formula right here, let me erase all the ink off of this so you can read it. Try to evaluate the derivative that's written below on your own first. Pause the video and do it. Alright, if you give it a shot, if you apply the rule, in this case x cubed is going to be our f of x, and 2x squared is going to be our g of x. So if we do this, it'll be the derivative of the first, which will be 3x squared, multiplied by the second, which is 2x squared, plus the first, x cubed, multiplied by the derivative of the second, 4x. So if you add all these up, you will end up getting 10x to the fourth if you simplify that. Now, it turns out we actually didn't need to use the product rule to solve this one, because if you just multiplied these two together, you would have gotten this as the same thing as asking for the derivative of 2x to the fifth, which would give you, hey, 10x to the fourth. So same thing. So we didn't need to use the product rule yet. It turns out we really don't need to use the product rule. We can get by with just the power rule until we get to talking about derivatives of trig functions and exponential log functions. Then when you combine those things and multiply them together, we're going to actually be using the product rule extensively. All right, so let's look at another example on the next slide. This one's a little bit more challenging. So also this one illustrates a little trick that you guys might not be familiar with when it comes to the power rule. You might be looking at this 1 over x and this 1 over x squared and say, I don't know how to take the derivative of that. You do. If you know the power rule, you know how to take the derivative of this. So give it a shot, pause the video. Alright, so if you first do this, again, we have to divide this up into two functions. So this function will be f of x. And so I remember I told you that if you knew the power rule, you could find the derivative of 1 over x. And that's if you rewrite it as x to the negative 1. Okay? Likewise, you can rewrite 1 over x squared as x to the negative 2, and now you can apply the power rule, okay? Hopefully none of you guys made the mistake of saying something like the derivative of 1 over x is just 1 over the derivative of x, which would be 1. This does not work. Do not do that, okay? That is not correct. You want to do what I did right here, where you rewrite 1 over x to some power as x to the negative whatever that power is. So if you didn't get this the first time, if you didn't realize how you could rewrite these two things, try to solve the derivative again now that you know the right thing to do. Alright, so if we go through and solve this, we're just going to get the derivative of the first, negative x to the negative 2, multiplied by the second, 3x to the 1/3, minus 5x plus x to the negative 2. Then we will add a little dot, 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 dot. We will add our first term, x to the negative 1, multiplied by the derivative of our second, which this will end up giving us x to the negative 2/3 minus 5 minus 2x to the negative 3. All right? So if you could do that, you're all good to go on the product rule. If you're still a little bit confused about how to apply it, come in class tomorrow with questions ready.